Welcome everybody. We are going to discuss about tree traversal technique today. So what do you mean by binary tree traversal? Any process for visiting all of the nodes of a binary tree in some order is known as binary tree traversal. Tree traversal is a form of graph traversal and refers to the process of visiting each node in a tree data structure exactly once. Such traversals are classified by the order in which the nodes are visited. There are actually three types of tree traversal. One is the preorder, postorder, and in-order. So in the preorder technique, we have to follow three procedure. First one is the visit the root and process it, then traverse the left subtree, then traverse the right subtree. This is the basic rules for the preorder. Now we are going to discuss how it works, how preorder traversal works. So there are simply three rules. First one is we have to push null onto a stack and set ptr is equal to root node. Similarly, there is a second rule. Until ptr not equal to null, we have to process each node n on the path and push its right child onto the stack. Each time, ptr will be updated by left ptr, and traversing will stop when the ptr will be null. Then backtracking will be executed or backtracking will be started. If the value of a stack is null, that time actually backtracking will not happen. But when the value of a stack is not null, that time pop and assign to ptr the top element of the stack. So we have to pop the top element on a stack and assign it to the ptr. If ptr not equal to null, then it will return to the step 2. If ptr equal to null and a stack equal to null at a time, the traversing will be stopped completely. So here we have to follow the first rule at first or at the beginning of the traversal. We see that the root of this tree is a, so we push the root node into ptr. So ptr is equal to a right now, and initially the stack is null. After that, we go to the second step. Since ptr not equal to null here, ptr is equal to a, we have to process this a. So now we process a and we push the right child of a into a stack. So what is the right child of a? This is c. We push it onto a stack and assign the left child of this a, left child of this node a to the ptr. That means the left child of a is equal to b. We set the value of ptr is equal to b. After that, we have to process new ptr. That means b. We have to process b, and we have to push the right child of b onto the stack, and the new value of ptr will be d, which is the left child of b. Then we have to process d, and we just push I, the right child of d, onto the stack, and the value of ptr will be updated by the formula ptr is equal to left ptr. Since h is the left child of d, that's why ptr will be updated to h. Now h will be processed, and we see that there is no left child no left child of age. That means new ptr will be the null. New ptr will be the null. So in this case, we have to proceed from a step 2 to a step 3. Here, what is the step 3? Pop and assign to ptr the top element on a stack. So here is the top element on a stack is I. Now it will go to the ptr value. So here now the new ptr value is I. Then since ptr is not equal to null, that means we have to go to the process 2 again. So here in here we have to process I right now. We have to process I, and we push the right child of I onto the stack, and the value of ptr will be updated by left child of I, which is k. So here ptr is equal to k, and the topmost value of a stack is now m. Now k will be processed, and again there is no left child of k. That's why ptr is equal to null. That's why we have to go to the step 3 backtracking process. So what will be the top value? What is the top value of stack right now? Which is m. Now this m is set to the value of ptr. So new value of ptr is equal to m, and it will go back to the second process. Now here the value of ptr is equal to m. That means the next step will be the process of m. We have to process m. Since there is no left child, so the value of ptr is equal to actually null. Since the value of ptr is actually null, we have to go to the third process. Now the top value of stack is e. We have to set this e to ptr. So new value of ptr is equal to e. Now we have to process e. Yes, we have to process e. After processing e, we see that there is no left child onto the e. There is no left child of e. That's why the value of ptr is equal to null. And since there is no right child, we do not have to push any value onto the stack. Since the value of ptr is equal to null, we have to go back to the third process, and here the top value of stack is right now c. So new value of ptr will be c. Now we have to process the value of ptr, which is c. Here we see that the right child of c is equal to z. That's why we have to push this g onto the stack, and the new value of ptr will be f. So we process c and push g onto the stack, and the new value of ptr will be f. Now what is the value of ptr? Ptr is equal to f. That's why we have to process it. After processing, we see that there is no left child of f. That's why the value of ptr is equal to null. Since there are no right child of f, that's why we do not push any new value onto the stack. Since the value of ptr is equal to null, we have to go to the process 3, which one is the operation of pop onto the stack. So what is the value of right now the top value of stack? That is g. So new value of PTR is equal to G. Since the value of PTR is not equal to null right now, that's why we have to process G, and there is no right child of G. That's why we do not push any value onto the stack. But there is a left child of G, which one is J. So the new value of PTR will be J. So we have to process G, and we have to set the new value of PTR is equal to J, which is the left child of G. Now the value of PTR is equal to J. That's why we have to process J. Since there is no left child of J, so the value of PTR will be null, and since there are no right child of J, we do not need to push any value onto the stack. So we have to just process J, and the value of PTR is equal to null. Since the value of PTR is equal to null, we have to go to the process 3. Here we see that the value of stack is equal to also null. Since PTR, the value of PTR is equal to null, and at a time the value of stack is equal to null, so traversing process is stopped, and we are getting the final sequence of preorder traversal, which one is A, B, D, H, I, K, M, E, C, F, G, J. Hopefully, you will understand the whole technique of preorder traversal, how it works. It will be very helpful for you. If you do not understand anything, or if you have any comments, please do your valuable comments into the comment section. Thank you.